Hello, Algebra 2. I hope you guys are having a fantastic day. Today we're doing 442, and this is on the rules of logs. So we recently talked about the properties, and the properties are more just like things that make your life convenient if you know them. The rules, because you can kind of figure them out whether or not you actually know what they are, or you can memorize them and then do things faster. The log rules are not the same. They're kind of things that you need in order for things to work out with logs. You can't just like figure them out. Okay, so log rules. The product rule is really kind of funky. And they're all kind of funky. But basically what the product rule says is that if you have a product inside the log, and only a product inside the log, then you can actually split that up as two separate logs with addition. So what that looks like is like if you have log of x times y, log base b of x times, it doesn't matter what the base is, log of x times y, that is equal to log of x plus log of y. Okay, so you can do it either way, right? This is an equal sign, so you can start with multiplication inside and then split it up as addition, or you can start with addition and then condense it into one log with multiplication on the inside. So like the directions for the next couple examples are expand or condense the following logs. Okay, so this first example is log of 5x. Okay, so there's a lot of things missing there. There's no base, which means it's what kind of log? You got it, it's a common log. And then 5x means it's multiplication. So you've got multiplication on the inside, log base 10. And so if you wanted to split that up, you could make that log of 5 plus log of x. Example 2 is the opposite direction. So you have addition of two separate logs. As long as they're the same base, you can combine them with multiplication. So you've got log base 2 of 4 plus log base 2 of 10. That's the same thing as log base 2 of 4 times 10. Okay, so that would be log base 2 of 40 would be your final answer there for like the condensed log. Okay, the natural log of 27. This one, try on your own, but there's like a couple different ways you can break it up. So go ahead, try that one on your own first. Okay, so what I did is I did the natural log of 3 times 9, which is the natural log of 3 plus the natural log of 9, and then 9 is 3 times 3, so I split that up into log of 3 times 3. So, and then I split that up into log of 3 plus the log of 3. So the natural log of 27 is equal to the natural log of 3 plus the natural log of 3 plus the natural log of 3. We have 3 of those natural log of 3's, so I just wrote it like this, 3 log 3, because I have 3 of them. So 3 times the natural log of 3 is the same thing. So yeah, fun stuff. Okay, next is the quotient rule. This one is similar to the product rule, but it just basically says that if you have a quotient inside the log, you can split it up with subtraction. And it's important that you note that the numerator always comes before the denominator. So it would be the numerator minus the denominator. So I'll show you what that looks like. Okay, so what I mean by that, you see I have log base b of x over y. It's log base b of x minus log base b of y, not the other way around. So it's always the numerator minus the denominator. Okay, so go ahead and try to expand numbers 1 and 3 and condense number 2. Okay, first one's pretty simple. So log of x over 5 is log of x minus log of 5. Pretty simple. For the second one, my final answer is in the highlighted box. But what I wanted to show you is that there's like so many different ways to write logs. So log base 2 of 4 minus log base 2 of 10 is log base 2 of 4 divided by 10, right? That's using the quotient rule. But then 4 over 10 is actually just 2/5. So that's a little bit more simple. So that would be your final answer because that's condensed. You took an expanded 2 logs and condensed it into 1 log. However, I just thought I'd throw it out there that that is also equal to log base 2 of 2 minus log base 2 of 5. And log base 2 of 2 is equal to 1, right? Because 2 to the first equals 2. So this thing equals 1. And log base 2 of 5 is still just log base 2 of 5. There's no way to simplify that. But, so what I wanted to show you is that log base 2 of 4 minus log base 2 of 10 is actually equal to log base 2 of 2 minus log base 2 of 5, which is the same thing as 1 minus log base 2 of 5. So there's like a lot of different ways to write the same log, which makes it hard sometimes to like figure out where to stop. But if I tell you to condense or simplify, right, this is condensed, this is fully simplified, right? This is condensed because we have one single log, but the fraction isn't reduced, right? 4/10 can be reduced to 2/5. So this is a better answer than this answer. Similarly, for example 3, we have natural log of 1 over 27. Using the quotient rule, we can do natural log of 1 minus natural log of 27. But the natural log of 1, or the log, any log of 1, is 0. So that's actually just negative natural log of 27. And we proved in the last part, in the product rule, that natural log of 27 is 3 log 3. So I just wrote it as a different way too here. So you can see that as well, but either of those answers would be fine. Okay, the last one is the power rule. I think this one's my favorite. And it's kind of the reason that like we love logs. So you'll see in a little bit why it's the coolest one. Okay, so the power rule basically says that like if you have the stuff inside the log raised to a power, you actually pull the power outside the log as multiplication. Okay. Okay, maybe I'll go over common mistakes in a minute once I go over this, but like there are a lot of common mistakes that I see, and I would rather you not make those common mistakes. So I'm preparing you ahead of time to not make them. Okay. Okay, so here's the power rule. It basically says that log base b, log of any base, of something x raised to a power, that's equal to the power times log base b of x. And you can also go the other way around. So if I have y times log base b of x, I can actually bring the y up as an exponent on the x, just like this. Okay, so it can go either way. Obviously, it's an equal sign. Doesn't mean I can just go from left to right. I can also go from right to left. And so, you know, we might do, so like for example, number 1, log base 2 of 3 to the 9th. Well, the 3 and 3 to the 9th is inside the log, so that 9 can come out front as multiplication by a constant. So that is equal to 9 times log base 2 of 3. Okay, so go ahead, try the other two, and basically the question or the problem is asking to like rearrange it. Use the power rule to rearrange it. Okay, so example 2, x plus 5 is the exponent, so you can bring that out front as x plus 5, the quantity x plus 5, times the natural log of e. Natural log of e just equals 1, so it's x plus 5 times 1, which is just x plus 5. And the last example is 2 times log of root 5. So you can bring the 2, because it's multiplication on the in front of the log, you bring that up as an exponent, so it's actually on the stuff inside the log. So root 5 raised to the 2nd power. So that's log of root 5 squared, which the square root squared is just 5. So log of 5 is your final answer. Okay, so now we can like combine all these rules together to help expand, make larger, or condense, make smaller, different log expressions. So here's an example of one that's moderately difficult. And you want to make sure that you're like following the order of operations and stuff like that. So what I would recommend doing in this case, so again, if you want, you can pause right now and try it on your own and just check your answer and make sure you did it right. If you think you have the hang of it. If you don't think you have the hang of it, you can kind of work along through it with me. So what I see is two things separated by division. So that's the first operation that I really see. So you have 8 times 3 to the 5th divided by 5 times 2 to the x. So I'm going to start with the quotient rule. So I'm going to take log base 2 of 8 times 3 to the 5th, and I'm going to subtract log base 2 of 5 times 2 to the x. Okay, so there's more stuff that we can break down now. So this one is just multiplication, so I'm going to do that first. So here's one of the common mistakes. Is a lot of times I'll see people go, oh, log base 2 of 8 times 3 to the 5th. Oh, that's the 5th power, and I can pull it out front. You cannot do that, okay? Don't do that. Bad, 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 bad. Because it's not 8 times 3 to the 5th, okay? If it was the whole thing, 8 times 3 to the 5th, right? Then you could pull that 5 out because it's the whole thing that's raised to the 5th power. But in this earlier case, right, it's only the 3 that has the 5th power, not the 8. So I have to wait to bring that 5 out. So first I'm going to use the product rule to split up the 8 and the 3 to the 5th. So at this point, I can actually simplify this one a little bit. Log base 2 of 8 is simple. What is log base 2 of 8? Well, what's 2? 2 to what power equals 8? 3. So this whole thing just equals 3. So I'm going to simplify that. Okay, next, I want to simplify this log base 2 of 5 times 2 to the x. Again, common mistake here. You are subtracting the entire thing, okay? So when I split it up, right, because this is a product rule problem, once I split it up, I still need to subtract the entire thing. So I would recommend like putting parentheses around it or overusing your parentheses or whatever so that you don't mess that up. Because now you want to be able to distribute that minus. So this is minus log base 2 of 5 minus log base 2 of 2 to the x. Also, log base 2 of 2 to the x, you should want somehow or another figure out that that's equal to x. You can either remember it from one of our properties, that log base 2 of 2 to a power is just equal to that power, or you can use the power rule and say, oh, that's x times log base 2 of 2, and log base 2 of 2 is just 1, so that equals x. So I'm going to simplify both of those things in one step here. So for this particular problem, you're pretty much done because log base 2 of 3 to the 5th can't be reduced. I guess you could bring out the exponent. You could make it 5 times log base 2 of 3 if you wanted to get everything out of the exponent there. But everything else is pretty much as simple as it's going to get because log base 2 of 5 is not a nice number. It's 2 to what power equals 5. It's ugly. Nobody actually knows. It's kind of close to 2, less than 3, but it's a nasty number. So I'd say this is a pretty good answer. Okay, here's example 2. Go ahead and try it. We're trying to condense everything into a single log. 1 log. Okay, and there's the answer for that problem. Okay, so go through those steps. I was tried to be really clear about my steps, so hopefully you can figure out where those came from. Okay, last thing is the change of base formula. So the change of base formula basically allows you to take a log from, for example, base 2 and change it to log base 10 or whatever. So notice that I have log base b of u changes to log base a, and a can be any base you choose. of u, so of the stuff on the inside, and log base a of b, or the original base. Okay, go ahead, try those two. And there you have it.